Back to The Explainer. Today, we're diving into a story of long-held assumptions, completely brilliant experiments, and a textbook-shattering discovery. We're going to literally unravel the mystery of the atom. Think about it. For thousands of years, humanity operated under one very specific, very confident assumption about the makeup of our universe. We thought the atom was the absolute smallest thing in existence. Well, spoiler alert, we were completely wrong. Looking at the timeline, we sat safely with this unquestioned idea starting way back in ancient Greece with Democritus, and it was solidly reinforced around 1800. But then, nothing, until the last decade of the 19th century. Suddenly there's this massive explosion of discoveries that changed literally everything. We went from centuries of stagnant certainty to a rapid-fire era of textbook rewriting science. So let's start with part one, the indivisible atom, and that stubbornly held 2,000-year-old belief. Way back when, the Greek philosopher Democritus set a pretty hard rule. He believed all matter was made of tiny ultimate particles. He actually named this particle the atom, defining it as something that absolutely cannot be split any further. The idea was, if you kept cutting something in half over and over and over again, the atom was that final indestructible piece. And this didn't just stay a philosophical idea either. Around 1800, the English chemist John Dalton provided concrete, scientific evidence for these atoms through his experiments with chemical compounds. So Dalton's work basically locked the door on the debate. The atom was real, it was indivisible, and science just kind of moved on. Or at least they thought they did. Which brings us to part two, the glowing tube mystery. This is where expectations totally fall apart. There's this incredibly curious handwritten note scribbled in the margins of an old textbook that perfectly captures the confusion of the era. A student just wrote, "How does discharge travel through a vacuum?" It hits the nail right on the head. If a vacuum is totally empty space, how on earth can electricity pass through it? To figure this out, scientists set up these crazy discharge tube experiments. First, they used a vacuum pump to suck almost all the gas out of a sealed glass tube. Then, they blasted the incredibly low-pressure gas that was left with a super high voltage. And guess what? The glass surface behind the positive electrode suddenly started to glow this really bright color. Something completely invisible was somehow crossing that empty space. Now, because these weird glowing emissions originated from the cathode, the negative electrode, scientists creatively named them cathode rays. But let's be real, giving them a name didn't actually explain what they were. Were they some weird form of light, a strange new gas? Nobody had a clue. All right, let's look at part three, testing the cathode rays. Enter our lead scientific detective, J.J. Thomson. J.J. Thomson wasn't just going to sit back and look at a pretty glow. He needed hard data. So he set up two incredibly ingenious tests to interrogate these rays. In his first test, he passed the rays through oppositely charged electric plates. In the second, he installed super powerful magnets right on either side of the tube. He was essentially putting these mystery rays through an obstacle course. And the results? Absolutely groundbreaking. When the rays went through the electric field, they actually bent towards the positively charged plate, which definitively proved they carried a negative charge. And when they hit the magnetic field, the rays were completely diverted. This was huge because it confirmed they weren't just intangible beams of light, they were actual physical material particles. But Thomson didn't stop there. By brilliantly combining the clues from the electric deflection and the magnetic diversion, he actually calculated their exact mass-to-charge ratio. This was the mathematical smoking gun, proving beyond a shadow of a doubt that these were distinct, measurable little things. He literally cracked the cosmic case wide open. Moving to part four, discovering the electron in our brand new subatomic reality. Thomson's calculations proved something completely wild. These cathode rays were actually material particles, vastly smaller than the atom itself. We now joyfully call them electrons. This was a massive paradigm shift. Electrons are subatomic particles present in the atoms of all elements. That prefix, sub, changes everything. It literally means there's an entire hidden world below the atom. So let's summarize this totally new atomic reality. That stubborn 2,000-year-old rule, totally dead. Atoms are simply not the smallest particles of matter. They contain negatively charged subatomic electrons. And to balance out all that negative charge, it turns out they also contain positively charged protons. Basically, the atom went from being a solid, unbreakable block to a bustling little container holding even tinier pieces. To put the sheer scale of this new subatomic world into perspective, just think about the number 1,836. A single, positively charged proton is exactly 1,836 times heavier than a negatively charged electron. So these particles aren't just tiny, they are wildly, crazily disproportionate in mass, yet they somehow perfectly coexist to build literally everything around us. Which brings us to a final, pretty mind-bending thought. Knowing that our ultimate, untouchable rule was totally shattered by a glowing glass tube and a couple of magnets, we have to ask ourselves, if the supposedly indivisible atom can actually be split, what else is hiding deep inside? I mean, if we were wrong for 2 millennia, what other magical mysteries are just waiting to be discovered? Thanks for joining us on The Explainer, and never stop questioning what you think you know.